Hey guys, I'm Abhay Upadhyay, software engineer at Akave. Before we dive into the live demo of Akave CLI, let's talk a bit about what we do here at Akave. Akave is a Filecoin layer 2 which inherits all the goodness of Filecoin, that is verifiability and data integrity, and extends it further with backwards compatibility with Web2 ecosystem, and is a highly available hot storage layer, making the transition from cloud storage to decentralized storage way easier for enterprises and devs. Akave is one of the fastest way to store and retrieve data on Filecoin. With high performance hot storage layer, all your needs for AI, ML, and deep uh, data can be fulfilled by Akave. Now let's move ahead and talk about why Akave. Why use Akave amongst all the decentralized solutions that exists in the market? Akave, our major focus is in Web 2 compatibility, making it easier to transition from current cloud storage solutions to Akave, that is a decentralized storage solution. First, first of all, let's talk about S3 compatibility. Akave O3, that is an S3 compatible API, can be used exactly as same as AWS S3 CLI commands. Just replace the AWS S3 API with Akave O3 API. That's it. That's all you need to do to transition from cloud storage to decentralized data storage. Akave helps save 80% of cost when compared to cloud solutions. Akave provides 100% traceability of your data using consensus and immutable data ledger, that is blockchain. Akave provides easy integration of data with wallets, allowing AI agents to autonomously interact with data and fuel this huge decentralized data economy. Now let's talk about how Akave works. So on the client side, there's Akave Go SDK, which can be reached using three different paths. That is Akave S3 compatible API or Akave O3, Akave CLI, or Akave JS wrapper. So once the data come to Go SDK, it's sharded and erasure coded, then sent to our Akave hot storage layers. We'll talk about this in detail in the next slide. So a Filecoin L1 is used as a worm or archival storage layer. Akave L2 is used for all the metadata storage, on-chain metadata storage of your file, so it's easily trackable and verifiable. Now let's talk about Akave's data security framework. So beginning from initial processing of your data, the file is chunked into 32 megabytes chunked, and data blocks are created. After this, the data blocks are encrypted using your private public key, public wallet key. Then the parity blocks are added using Reed-Solomon algorithm, which is an erasure coding algorithm, and it's distributed across the network. Now, retrieval process. The node collects all the data from different nodes, which is available in the blockchain, trackable through blockchain. Once retrieved, data is reformed back on the client side. Even if some chunks are missing, it can be rebuilt using Reed-Solomon recovery algorithm. Then after decryption, you get your original file back. Now, these are all the links if you want to join our ecosystem and know more about our progress. Let's move on to live demo and see it in action how Akave CLI works. Let me move myself from here. Good. Okay. Let's see. Akave CLI help. We have commands ready. Akave CLI IPC. Let's create a bucket. So we use object form of storage test just test. Let's do this one. And so we are creating a bucket here, which is object storage structure. First you create a bucket, then you upload your data into that bucket. Let's copy this because we'll need this a lot. All right. Okay. Now let's check the bucket. IPC bucket list. Okay. As you can see, this is the bucket that we just created. Ignore this one, I created it earlier. Okay, so we have the bucket over here. We'll upload some data. To upload the data, let's create a random data. This is the command used to create some random bytes of data. We'll create a 100 megabyte file named text.txt. As you can see, it's a 100 megabyte file. This test.txt. We'll upload this file to our bucket that we just created, Akave CLI IPC, then bucket name, you give file path, then rest of the stuff. Now, this might be good moment to talk about difference between IPC command and file streaming commands. So the file streaming commands, they don't go through blockchain. So they are way quicker than IPC commands. IPC commands take a lot of time because they have to go through on-chain transaction, wait for their transactions to proceed, and then the file actually gets uploaded to the nodes. So yeah, as we can see, it took me a minute to upload the data successfully. We can see over here, we got the root CID back. We got the name of the file back. We can also list the files. You see, this command can be used to list the files in your bucket to provide bucket name as an argument. So we can see this is the file we just uploaded. This is the size of file that is 100 megabytes. Now what we'll do is download this data back. Demo download. Okay, we'll be downloading our data over here. Let's run the download command. Our CLI IPC file down. So in download, we need to provide the bucket name, test underscore 001, file name, test.txt, then the download path that should be used, demo download, and that and rest of the nodes. Okay, let me copy it from here. Good. Yeah, as we can see, the file has been successfully downloaded. Let's check the uh, directory that we downloaded the file in. As you can see, a 100 megabyte file named test.txt has been successfully downloaded from Akave's node. That's it. Also, I'd like to mention that I use the pre-compile Akave CLI. You can go to our docs.akave.ai, which is right here also here, and you can use these commands depending on your operating system to build the pre-compile for Akave CLI. Let's also check on our Explorer and see the transaction that we just did. Okay, so this is the transaction of commit file that I just did. This is my wallet address, and if we go in the details, you can actually see the test.txt and the file size to confirm that this is actually the file that we just uploaded. That's it about Akave CLI. Hope you guys enjoyed the video. Thank you.